Yeah, hi everyone, Mr. Markwick here again. Today's video I'm going to show you how to sketch a parabola by first completing the square. So I'm not actually going to go through much about completing the square. I'm hoping you guys already know how to do that. But coming up with the key features of a parabola in order to sketch it by first completing the square. Now, the equation we'll start with will be in standard form. So remember, standard form is y equals ax squared plus bx plus c. Great thing about standard form is we can read the y-intercept straight off of the equation. It's that constant term. And we're going to convert that standard form into turning point form, which is y equals a x take h all squared plus k by completing the square. And then that'll give us the turning point in terms of h and k. We'll already have the y-intercept, and then we'll do factorize this using difference of perfect squares to give us the x-intercepts. And that's pretty much everything we need, all the key features we need to sketch a parabola. So let's start with an equation in standard form. I've got one here. There it is. So let's move that up a bit. But y equals x squared plus 8x take 8. Now remember, in order to complete the square, we need to add the value of b over 2 all squared and also subtract that to balance it. So we're looking for the coefficient or the x term, which in this case is 8. So I'm going to do y equals x squared plus 8x. Now I'm going to add, I'll keep this red for you, so add, in this case it's positive 8 over 2 all squared. I'm also going to subtract that to balance the equation. Okay, and that constant term remains there, which is minus 5, which in fact is our y-intercept, but we'll write that down after. So 8 over 2 all squared, 8 divided by 2 is 4, 4 squared is 16. So we're essentially got an equation that looks like this now. Y equals x squared plus 8x plus 16 minus 5. And if you remember, this is why we actually do that, why we add b over 2 all squared and subtract b over 2 all squared, is so that we can get, in those first three terms, a perfect square. Alright, so x squared plus 8x plus 16 is factorized y equals x plus 4 all squared. And if you think of it in terms of sum and product, two numbers that add to give you positive 8 and multiply to give you positive 16, and at this point your number is going to be the same number. What I mean by that is it's going to be 4 and 4, or if it was 6 plus 6 and plus 9, it would be 3 and 3. So you ended up with a perfect square there. Alright, now I'm just going to do minus 16 take 5, which gives me minus 21. Just keep that in black, sorry. And now we're at turning point form. We've actually got the coordinates of the vertex. In fact, let's start writing stuff down here. Let's use green. So I know that the y-intercept is 0, 5. Reading that straight from the standard form. My vertex is now minus 4, minus 21. Okay, they're the coordinates of the vertex. Now, to work out my x-intercepts, I need to factorize this using difference of perfect squares. Okay, essentially where I'm at the moment is I have two terms, x plus 4 all squared and 21 subtracted by this minus sign. Remember, if that minus sign was a plus sign, there would not be any x-intercepts. Okay, you couldn't factorize that using difference of perfect squares. If this term wasn't here at all, if it was just the perfect square at the front here, say for example x plus 4 all squared, then it's just a perfect square, there's only one x-intercept. In this case, there is a minus sign in between those two terms, so we can factorize this using difference of perfect squares. So I'm going to set up my two sets of brackets. At the front of each of those brackets goes x plus 4, x plus 4, which is the square root of x plus 4 all squared. At the back of those brackets, I'm going to put the square root of 21. Now, 21 is not a square number, so I'm going to keep it as a surd. So, root 21, root 21. And in between those, I'm going to have a plus and minus. All right, and that's pretty much it in terms of my x-intercepts for exact form. So, if I was to then solve this using the null factor law, remember, y would be equal to 0. So 0 equals x plus 4 plus root 21, or x plus 4 minus root 21. I get to the point where I've got two x-intercepts. They would be minus 4, take root 21, and 0, and minus 4 plus root 21 and 0. And if you really wanted to, guys, if this was actually your x-intercepts, and that's a little bit hard to picture, I know, you could actually just put that on a calculator. It'll give you a decimal number, and that'll help you actually plot that onto your Cartesian plane if you were to sketch it. So for this example, I'm not going to sketch it because it's got a vertex of minus 21 to start with, so it's going to be a bigger graph than what we're usually used to dealing with. So I'm not going to sketch this one, but I've given you an example on how to work out those key features. Well, the four key features really you've got here, haven't you? Okay, you've got the y-intercept, you've got the vertex, and you've got the x-intercepts. The other key feature is the axis of symmetry. Remember, the axis of symmetry is the x value in your vertex. Okay, so the axis of symmetry, if that was part of the question, give the equation for the axis of symmetry. It would be x equals minus 4. All right, guys. So that's how you would, I guess, come up with those key features in order to sketch a parabola using the method of completing the square. Hopefully, when you get to this point, okay, you got a nice square number. In fact, let's just, for argument's sake, let's just say we got to the point where we're there. We've got x plus 4 all squared. Let's say take 25. Okay, we know 25 is a square number. Next step down would be x plus 4 plus 20, the square root of 25, which is actually 5. X plus 4 take 5. All right, and then we can actually collect these like terms or these constant terms, which gives us x plus 9 and x take 1, which gives me two x-intercepts of, in this case, again, substitute y equals 0, use the null factor law, x would equal minus 9, or x would equal positive 1. All right, I'm giving you the coordinates of minus 9, 0, and 1, 0. Now, guys, this isn't to do with this question. Okay, this is just showing you that if you did have a square number, and hopefully some of the questions, they're easier if they are set up and you've got a square number there. Okay, because you can get to a point where you've actually got a whole number and you're not dealing with surds. A bit of a clue, if the question says given an exact value, or then you're probably going to have a surd as an answer. But depending on how nice your teacher is when they're creating your test, they might give you a nice whole number to work with as well. And they're obviously easier for us to sketch when it comes time to plotting those on your Cartesian plane. Anyway, guys, the process is the same. Hopefully this helps, and thanks for watching.